Hi there. In this video, we'll learn about how to find out the list of open files on a Linux system. Many of you have used Linux, would already know the command for that. And the command for that, if you don't know already, is lsoff command. lsoff will give you a list of open files on your system. Yeah, there are certain files which may not show if you logged in as a normal user. If you run this root user, you'll not get this permission denied messages you would have seen some time ago. So lsoff has lots of switches to control what all things you can do with it. You can see a whole lot of switches in here, right? You can look up when I say lsoff, and it's a minus myself, it says illegal option character. Actually, I think it understands lsoff -h for help. Some of the commands don't understand long options because they're not part of the GNU Cordials package, perhaps. So there's a separate utility, and yeah, you can see -h for help. You can actually look selecting based on the command. You can also look up open files by the process ID and a lot of other details. My intent is not to teach you about lsoff command, but I'm going to tell you how this command gets these details, because if you know that, you don't need this command. You can script it on your own. These tools are useful for systems administrators where they master and learn all these switches. But if you're a power user, you want to do it by hand on your own. Maybe you run on a Linux system where lsoff is not installed. Then what do you do next? Well, how do you find out the list of open files then? If you know what lsoff does to find these details, you can perform that on your own on Linux. And an interesting fact I should also tell you is that in Linux, all these features are so good and so easy. And I'm going to challenge people who work on other platforms, maybe those who work on Solaris, HP UX, macOS, or even FreeBSD, to try this out without using any special tools, just by using basic commands. Well, on Linux, information about all the files open on your system is there on a per process basis. First, let me show you how to find out what all files are opened by a given process. Here in another terminal, I have opened up a Python shell. It's an IPython shell, and let me find out the process ID of it. I'm just going to type os.getPID, and it is 82312. Now, if you just look up /proc/82312, look up this folder, you get details about this process. And under this folder, there's a subfolder called FD. And this folder will tell you all the files opened by that process. So we just run this command. You can see it shows a lot of numbers in here. These are all the file descriptor numbers that are assigned for this process, or what all files it is opened. To find out what all files or descriptors are mapped to, you can also put a ls-l here. This represents a standard input. This is standard output. And I guess you know the standard error is 2 here. Looks like it's ordered in the lexicographic order, not in the numerical order. File descriptor 10 happens to be a socket. If you say a socket :something, this means it has used a socket API for establishing some socket connection. Maybe a listener socket. We don't know about that. We need to look up the source code of this program. Yeah, it looks like this socket is created here. There are multiple sockets being created. But these files are opened by this process right now. You can see the history.sqlite. And in what modes it's open is also listed in here. You can see sometimes some files are open in write mode. Some files are open in read-write mode. So what I'm going to do now is I'm going to open a file manually. I'm going to say fd is equal to os.openoff. I'm just going to use a file, let's say testfile.txt, which exists, I believe, in the current directory. And I'm going to open it with os.o_rd only. Opening the file for read mode. Now if you look up this folder, you should be able to see that the file that I opened, it's here. R- indicates open for read only. The W is not set. You can ignore the X, right? It's just there, set as it is. They have not modified it. So this only the first 2 bits here is relevant. This file is open for read only mode. It's only going to read, and you can see the file name that corresponds to is testfile.txt, and the file descriptor number assigned for that is 12. And this process will see that fd is equal to 12, right? We can see that right here. If I also say fd is equal to os.open of new file.txt, and I'm just say os.o_wr only pipe o_create. This is how we create a new file, right? Create a new file and open it for write mode. If you just look up Here I should use FD2. The old FD is now going to leak. Sorry about that. Okay, anyways, I should have said FD2 there. I will not be able to close the old file. So if you just try it out here again, you could see the team, right, which has write open in write mode. So you can see file descriptor number 13, which corresponds to this particular file, new file.txt. Because it's not passed the mode bits, I think the execute mode is enabled on the file. That's why it's shown in all greens. So when you open a file with o_create, you will also need to pass a third argument, the mode bits. What should be the mode bits? Otherwise, it'll take some garbage data. So anyways, so you can find out what all files are opened by a particular process this way, right? So if you want to find out across the system, it's quite easy. You can actually say, look up ls/proc/ all files that start from 0 to 9 /star. So everything that starts from 0 to 9 represents process ID folders. Under the process ID folder, look up the FD folder. Under that, look for all the entries in here. All of these are the file descriptor numbers of all the files opened by every single process across my system. You can select it on a per process basis. You know how to do that now. But if you want to do it on the entire system, you can check it up this way. And now once you get these details, what you can do right now is you can actually use a loop. I can say for f in this particular folder. I'm using the Z shell, so it prints the secondary prompt in a very intuitive way, but you can run the same command even in your bash or even bone compatible shell to a large extent, because this is just bone compatible commands that I'm using, bone compatible shell command, right? It's a standard shell feature. I can use do, and I could just say, this time I'll say readlink $f. Readlink command will read the contents of a symlink and substitute it with the file name, right? The actual file that the symlink points to, you can get to know by using readlink command. And run done here. Now this entire scroll, you can see what all files are open at this point. But I use the word file, it may not be files. These are all representative file descriptors. When you open a socket, you get a file descriptor. When you use iNotify API, you get a file descriptor. If you use epoll, you get a file descriptor. So it shows all the file descriptors. Even pipes are represented as file descriptors. But if you want to look for files on disk specifically, you can actually do a search on this. So I can say pipe. I could say grep. I'll use fgrep, or maybe I can use grep. Look for all lines that start with /. These are very likely files, because the ones which is called socket and pipe will not start with a /. You see pipe : something, socket : something, right? But everything that starts with a / is part of your file system, starting from root file system, right? You can see a whole lot of files being listed in here. Now, from amongst all of these files, the same file could have been opened multiple times, which could be like device files like these. You can filter it out by using a sort -u. When you sort them, it will sort it lexicographically, and -u switch will make sure that duplicate entries are removed, so you get unique entries. If you want to find out how many files are open at this point, how many unique files are open at this point, wc-l. 125 unique files are open on my system right now. But I don't want to look up unique files. You don't want to really look up unique files. You want to just find out how many file descriptors are created in total. So wc-l at the end, and you get 476, right? So you can actually get to know the details about all the files open on your system by using this technique. So this is how you do it without using lsoff command. lsoff is just a glorified wrapper on a tool that actually navigates /proc file system. It's just built as a tool that navigates /proc file system. Look up the FD folder, read all these entries, and prints it in a very nice formatted output, and gives you lots of switches to control various aspects in here, right? So if you know how you can do it manually, now you will have a better understanding about how lsoff command works internally. So this is about a short video to know about list of open files. I hope you find this video useful in your work, especially. So if you have a requirement where you want to find out who is opened a particular file and so on, all this can be done with this technique. So do let me know if you have any questions or doubts in the comment section. Thank you very much. Hope to meet you in future videos.